This video webinar is presenting some of the possibility of the new digital manufacturing technology that we usually call additive production applied to lighting, and specifically the experience made within the framework of the EU-funded project ReproLight. This video is not presenting in detail the technical aspects of digital production. Instead, is introducing hotspot opportunities offered by these fabrication technologies in terms of novel design approaches, highlighting how the design of the product can allow to fully exploit these new fabrication techniques. Let's go to start with the presentation. First of all, we are going to introduce our organization, who we are, and what is our mission. Grado Zero Space, shortly named Grado Zero, is a design, prototyping, and manufacturing company specialized in innovative materials, advanced and digital manufacturing, sensor and sensing technologies, including IoT and industrial IoT. Our mission is to transform materials and technology into innovative products. The men responsible for this project were myself, my name is Enrico Cozzoni, and I am the R&D team leader for Grado Zero Space, and my colleague Claudio Pucci, that is a senior designer in Grado Zero. The following summary is showing how the presentation is structured and what you will see in the next slides. The topics that we will present are the following. First of all, we will introduce you in the world of CAD modeling and morphing, mainly focusing on geometry personalization. We will then present you some example of design for additive production with the aim to show you how it is possible to appropriately use the CAD modeling for generating several product concepts that can be digitally manufactured. We will then present the lamp shading components developed for the EU-funded project ReproLight. And finally, we will present you a new design approach explored with the aim to produce a lighting product only by digital manufacturing. The aim to explore the world of CAD modeling and morphing is that to present a powerful tool for which explore the possibility to personalize product geometries. One of the huge advantages in using additive production is that to have a freedom of geometry. We use this advantage studying and producing customizable decorative accessories for the lighting sector, linking together polygonal CAD modeling and additive technologies. This resulted in an algorithm developed in 3D Studio Max software for obtaining personalized lamp shading elements. Starting from two geometries having the same mesh points, it is so possible to generate an infinite series of morphing geometries, connecting the beginning mesh with the final mesh. Also, bio-inspired geometries are possible instead of regular mesh. Being the geometry developed to be used in lamp shading elements, the meshes were optimally studied for providing specific lighting shades, working on the mesh's geometry and on the color. Two videos showing in motion view the morphing geometries. Two products of Trilus groups within the ReproLite project were used as basis for generating the geometry personalization. One pendant luminar product and one linear luminar product. Several personalization geometries for lamp shading components were generated on the basis of these two products, mainly divided in three groups: housing and reflector manufacturing, lampshade designs, customizable installations. In the following, some examples for the pendant luminar product. Housing metal, smooth. Housing metal, regular and with heat dissipation. Housing metal, complex and with heat dissipation. Housing plastic, complex and with heat dissipation. Housing plastic with color gradient. Housing plastic with modular design. Organic shape. Organic shape with transparent mesh. Metal bio-inspired shape for lamp shading. Metal regular shape for lamp shading. Metal regular shape for lamp shading with a second geometry, different. Metal regular shape for lamp shading with a third geometry, again different. Plastic bio-inspired shape for lamp shading. Plastic regular shape for lamp shading. Now, some example for the lamp shading coverings for the linear luminar products. Also with anti-glare grid. Also including the reflector. Customizable installation were also considered using additive production technologies. Designing connector rounded elements having both aesthetical and functional purpose. These connector elements, other than give a speciality to the product and the possibility to personalize the installation, can contain functional modules such as Bluetooth or projectors or other. Here, the two products of Trilus Group used within the ReproLite project and the personalization manufactured within this project are presented, starting from the SONNOS pendant luminar and its personalized lamp shading elements. Together with SONNOS pendant luminar, also E-line linear luminar was taken as base product for lamp shading personalized coverings manufactured by Additive Production Technologies. Two different additive production technologies were used for manufacturing the lamp shading components. Stereolithography through laser for the E-line luminar and fused deposition modeling for the SONNOS luminar. The realization quality in terms of layer thickness of the two technology is here reported and showed in two circular windows. Some details of the fused deposition modeling for the SONNOS luminaire, showing the interfiber bonding region and the void that can occur when the layers did not fully adhere one to the other. Again, one slide with the SONNOS lamp shading elements, 3 different geometries, and one rendering of the product. Some details of the stereolithography, technique used for the E-line luminaire, showing the polymerization grades between the layers. Again, one slide with the E-line lamp shading covering, and one rendering of the product. For demonstrating the full impact of the additive production technology, it was decided to make an experiment on a totally new concept of lighting product. Design of the new cylindrical suspension luminaire was born from the desire to explore the use of additive production using laser technology and metals, integrating in the metal core the heat sinker and providing a laminar internal structure to reach the limit in lighting design regarding the approach known as design for 3D printing. To realize the final experimental demonstrator that it will be ready for online orders, small series production on demand on the Grado Zero website in January of the next year, were also used components supplied by the company BJB. Specifically, a spotlight connector, the terminal block, and the reflector. Other components have also been supplied by BJB, reflector with different beam angles and diffusing screen that will allow to the product to have a wide range of mountable optics combinations. The video shows how the design was so focused on a special internal structure for this product that can be easily created with additive production to allow an honeycomb-like structure which guarantee lightness in the product of the monolithic part, where traditional technique would have required the production of several parts to be joined. Another advantage exploited was to integrate in a monolithic-like structure also the heat sinker, as already told. The video shows the metal housing redesigned by Grado Zero, its laminar core structure, its internal components disposition, including LED spotlight connector, reflector, LED spotlight driver, terminal block, the heat sinker integrated in the metal core, some section view of the product and its assembling view are also showed. The aim of the new design was to achieve an initial simplification of the number of components compared to a classical product, and consequently to obtain advantages in terms of volume and weight reduction through a design specifically conceived for additive production manufacturing, where the undercutting constraints and realization problems due to traditional technology can be overcome, fully exploring the potentiality of the new design approach. The lesson learned by this presentation, it is divided into four main points. The first is that design and digital manufacturing technology are strictly linked along all the life cycle of a product. For efficiently used additive production technologies, this link is absolutely necessary and allows the digital technology to properly work. Second, this link can be used to explore new design approaches for novel personalized products, as we have showed along all the presentation. Third, additive production can support the realization of products with new aesthetic and functionalities, as well as completely new designs, unimaginable with conventional production technologies. Fourth, that's why for fully exploit all the benefit of the new digital production technology, new product design concepts are needed, as those we have tried to show within this presentation that we hope you have appreciated. Thanks.